Alright, so yeah, when this dog pulls out as far as it can, to be 60 feet away from that point, and it's going to notice itself swinging in a circle. Well, it gets up to here, and that's all fine and good. And that 60-foot leash is partially going to cut off by 10 foot of barn, so we got 50 foot of leash left. Okay, it's a bad picture. Well, the words are my way, so I guess I have an excuse. This 50-foot radius, this is still 50 now, this little curve, that's going to go beyond this by 20, and it's going to start to bend some more. So I really have three regions here. I have a half circle, where the radius is 60, and then I have a quarter circle where the radius is 50, and then I have a quarter circle where the radius is 20. So really that's not that bad. If I told you you had to add up those three things, I don't think you would have too much of a series of nightmares like some people were saying they were having about this problem. Yeah, this was originally on the test. The other teachers made me take it off. I thought, okay, fine. All right, so here we have half of a pi r squared. And then we have a quarter of a pi r squared. R keeps changing though. Pi times radius squared plus another quarter of a different pi r squared. Smaller yet still. Okay, it doesn't say if I wanted to exact or approximate. Let's go approximate. Half of 60 squared is 1800. Quarter of 50 squared, 50 squared is 2500, right? And I'm going to take a quarter of that, so it's 625. And then I have a quarter of 20 squared, which is 100. So 725, it looks like I have 25. Well, isn't that cute? 25 square feet, actually. If you wanted to have an approximate value, you just put that in your calculator for that. Okay, here's another one I took off. This one's, I think, considerably harder. I have a rhombus, I have some tangents, and I know a length of a chord, and I'm supposed to find this orange or this purple area here. Now, I had one that I made up that I put on homework not too long ago, and I did it one way, and I think there's an easier way to do it. So I think what I'm going to do here, instead of taking the circle minus these two things here, I think I'm going to actually, because of the arcs I'm able to find. Now you could do it that way, you could do it the way I'm about to do it, it's fine. I think I can actually split it into these four regions, these two sectors and these two triangles, and I can find the area better that way. So I'm not going to write my plan. I guess it's two sectors and two triangles, and everything's the sectors are different. The triangles are actually identical. Let's talk about that for a second, how I know this. First of all, this is a rhombus. This is a 43-degree angle. I also know this is 43 degrees because it's a rhombus, and rhombuses do that. Also, since this is two tangents, I know this angle of the circle, this arc here, has to be this arc in here. This central angle has to be supplementary to the one out here. Remember this kite where these are perpendicular, that's 180 degrees of the kite. So this and this have to make another 180 degrees of the kite. So this is 137 here. So this is a 137 degree arc. I know that 137 minus this arc divided by 2 is 43. 137 minus x divided by 2 is supposed to be 43. I'm just trying to get my my arcs all sorted out here. 137 minus x divided by 2 is 43. So 137 minus x better be 86. 137 minus x is 86, so I'll basically take 137 minus 86 and I'll get x. Correct? What is that? I can't do that in my head. A lot of stuff I can do in my head. Pretty impressive. Add 100 to that. 49, really? Okay, I'll just do this again. I can't type buttons correctly with this pen and this thing fast enough. 51, yeah. Okay, so this is 51. So this is a 51 degree arc here. Why did I go all that trouble? Well, I'm going to want to know the areas of these triangles and that kind of thing, and I need to know the degrees of all these arcs. This is a 51 degree angle here. I know these two are the same. Why are they the same? Why does this arc have to be the same as this? Well, this is a rhombus, and I know things like the angles at the opposite ends of the rhombus are congruent. I got all kinds of symmetry. This angle here would have to be the same as this angle here, and if that's the case, then the part inside this angle has to be the same as the part inside that angle, or the part I guess this is the rest of 90 outside here if I extend that tangent. Same thing here, so this arc should be the same as that. Anyway, they're the same. If you don't believe me, we can go to a long discussion about this. If I connected B with F, it would go through P, so I have all kinds of reflection symmetry there. And believe me now, this is also 8 centimeters. I have all kinds of happy rhombus symmetry all over the place. So these two things have to make 360 with those two missing parts. So if I took 51 plus 137, what is wrong with my 1 button? 137, 7, hello. Okay, now I can't type 7. Interesting. All right. 188, so the other ones have to be the rest. What is going on? 0, minus. May your calculator work better than mine. Not negative. Would you seriously stop doing that? Can I just go back and go delete second answer? Thank you. We'll divide that by 2. So each one of those is, yeah, you didn't take my 2 either. 86. Okay, so these, that took a long time. Those are both 86. Okay, so now my point is, and we've done this before, I know an angle and an arc, I can figure out the radius and all that kind of stuff, because I need to know radius for all these things. This common technique, these are going to be both 43. And I know this 8 is exactly 86 360ths of a circumference. From that, I can find out what r is. Done it before, so I'm going to save space here. I need to take 8 divided by all this other junk. 8 divided by, oh gosh, this calculator. Divided by 2 pi, first of all. Not 2 to the pi power, would you seriously? I'm not going to make you watch this. Turns out to be 5.34. Okay, that's the radius of the circle. That's nice to know because now I can use that. I need the radius for the sectors. I need the radius. I guess I don't need for the triangles. Triangles I need base and height, so I need to know this little thing here. I know this is a 43-degree angle. I know that the hypotenuse is 53. Where can I put that? How about up here? H over hypotenuse. That's adjacent over hypotenuse. That's cosine. That means that H is going to be, it's really close to 3.9. Okay, so that's 3.9. I can then also find the length over there. I'll call that B, although it's half of the base. I know that opposite over hypotenuse is the sine of 43, which tells me that B is, all right, it's about 3.635. If I double that, I get something like 7.27 for that part of that triangle. So in the end here, what I have, oh yeah, I have some angles to deal with too. I have sector 1, which is 137 360ths of a pi r squared. You know, I probably could add these angles and say that, oh yeah, I could do that. That'd be kind of slick. Instead of saying 137, watch this. I'm going to say 137 plus 51. I really have, how much of this circle here? I have 137 plus 51 of it. 51 360ths of a pi r squared. R, I figured out, it's 5.34. Plus, then I have 2 of these triangles. 2 of the triangles, that seems funny to go 2 times half, times base times height. There's a lot of calculation and all that. Altogether, that becomes, turns out to be something like that. Yeah, my calculator's really no fun to watch right now. Okay, that's really all I can think of to throw at you right now. Here's some other questions that I either made up in class or you asked me from class. You know, this kind of thing happens a lot. We find this little thing called a segment of a circle. Sometimes I call it the sunrise. It's the sector minus the triangle. All these I will upload to Blackboard, and oh, this is from the quiz. I'll upload these to Blackboard and call it like review day or something like that, because it's going to have all the static versions of all these. Yeah, a lot of these are quiz problems I did in class. You might remember that and go, oh, wait, he said he was going to upload that, and I didn't see it. Anyway, here's one I made up. Here's an interesting one about the area of a sector. One way to find area of a sector is you can treat it like a triangle where this is the length of the base and this is the height. Half times base times height is the area of a triangle, and it actually works for sectors. If you happen to know the arc length and the radius, you can use that as base and height of a triangle. So there's some fun gems in there. Here's one not to forget. Yeah, as I was going through the stuff about reviewing the hints I gave you on that review document, by the way, which is also online, but I gave you a copy of it. All that stuff is explained, and it'll be, the written examples are drawn here. Okay, I don't need to ramble on. You'll see this stuff when you download the static version. Okay, good luck on the test. Have a good day off Tuesday. I'll see you Wednesday.